look at the the script here on the left. It's JavaScript. Um, that's all the code right here. And so I didn't really code it to work as like a circle yet, but it kind of does this kind of locally. Everything space is supposed to be normal, but when something gets further away from you, then it turns into a fractal. So you got these compressed objects that are arbitrarily an arbitrary distance away from you will still it will still be at least bounded here. So you can see really far away things. So I'm going to try to go up into the left and try to like find these dots that are up here. So yeah. Anyway, it's kind of cool. Up, left, up, left. This is crazy. Anyway, I just wanted to show you guys that. If you guys want me to do some JavaScript coding, I know there's other people on YouTube who do it, so I'm not necessarily the best person to do it, but it's definitely something I can probably do. Anyway, I'll stop that.
Alright guys, so I updated the code a little bit, and as you can see, it's radially symmetric. So now I basically have a little world that I can move around in, and as you can see, I also made these little boxes into like moving bugs. I sort of didn't want them to just move randomly all the time because they were too jittery, if you will, and I didn't want them all to be consistently moving. I wanted them to kind of pause and sort of, as you can see, this one moves around a little bit and then pauses again. So he has sort of this there's a delta, which is kind of the state that of how much movement they want to be in, and that basically just changes. There's a lot of repeated code here, which can be taken care of with lambdas if I knew how to really do them in JavaScript, or if JavaScript supported them. But I'm not really doing that, so this looks like a lot of repeated code in a procedural sense. But if I used lambdas and passed around functions and stuff, that there wouldn't be as much redundancy here. But back to explaining the movements here. Delta is just a variable for just an integer stored for each one of these guys, kind of storing how much they want to move, and then that controls how often this sx or sy, which is the change, it's basically the speed, which is going to be 1, 0, or -1 in either x or y direction. And then those are what's used to change these ax and ay, which is the actual positions. So I kind of just played around with it just to make them feel like they're just sort of living bugs, but not too jittery and too crazy, so that I couldn't actually sense where I was in this world. So I want the sense of moving down. As you can see, it looks like I'm moving down right now, because they're moving up for the most part, in relative to me. So as you can see, anything that's far away, the further away it is, the closer it gets to this circumference. So this is sort of a game design idea that I've wanted to make for a long time, and it almost looks like I'm kind of almost like on a planet, but it's not true that it, something goes around the horizon of the planet. That's not how it works. Basically, I'm just using polar coordinates, and I'm calculating basically the distance that something is from me in the center. And in the Cartesian coordinate world, where there's just regular x and y, it would just be this infinite plane. But basically I calculate the distance in that plane, and then I sort of use a function which then takes that distance and maps it from basically from a 0 to infinity distance to a 0 to whatever this circumference is distance. And then it doesn't really apply it linearly, but it sort of applies it, and it divides the distance such that the further away you get, it asymptotically gets closer to this circumference. And in order to get really close to me here in the center, you have to actually be very physically close to me in the Cartesian world. So if I want to go way out here to one of these dots out there, it'll take me a while. But I can sort of just do it. I just have to push myself along. And I like this because it sort of is a mix between a mini-map and a regular two-dimensional view of a game. Because there's a lot of games that have different levels of maps. They have mini-maps. If you've played Zelda, you have, local things going on. And then you can sort of pause the game and zoom out, and there's like a map. But I don't like that. That's okay, but I kind of prefer to have this idea where everything is one screen. Your mini map and the gameplay all in one. So if basically I can do something here, I can interact, talk with people, solve puzzles, get keys, whatever. Maybe go around doors. Maybe I'll make like a maze version of this where there's actual walls. And I want to see what that looks like too. I might try to make like a labyrinth where there's rooms and things like that. And I'll show you the code for... I should just show you guys the code for how this works as far as the distancing. So you have a ratio that basically determines how spread out they are. So if the ratio is small, what'll happen is they'll all be stuck around the circumference, and then until I get really super close to something, they'll basically teleport to the center, almost, and then just teleport back to the other side. It's too spread out. And if the number gets too big, then pretty much everything gets clogged up in the center here, and you don't have a lot of space. So you kind of want to keep it in a way that you can see what's going on, but it's not taking up too much of the screen. So yeah, I'm not sure if I've fixed that correctly though, because I think one of the problems I was having was the step size was too big. So I want the ratio not to increase, necessarily too much, but maybe I just need to make it so the steps that I take are smaller relative to, I guess, the size of my box or something like that, because I do want to have this space. I want things that are further away to be, maybe closer to the edge, but I also want to be able to get right up next to things that are close to me without just skipping them around. I can show you what that looks like. So if I change the ratio to 20 here and then I reload it, as you can see, it's like everything is far away most of the time, which is pretty okay. But then when I try to step close to something, it's like every step is like a mile, is like 20 feet. So I'm not sure if I'm really okay with that. But anyway, this ratio is sort of something that I did the math, and the way I scale everything happens to turn out into this. Basically, it's like a shifted 1 over x plot. So it's like you take y equals 1 over x and you plot that. And then you just take that entire graph and you sort of shift the entire thing to the left a little bit. So instead of, when you give it 0, instead of it, jumping up to infinity, you jump up basically to your constant, like the size of your of your guy, essentially. This little constant here, which I have set as the number 20 up here. And so if basically the distance from me to something else is 0, it ends up being 20. But anything else, it gets really, a lot smaller. And then basically for the circumference, we basically subtract that. So I basically take that 20 and then just subtract whatever the scale is. That way, anything that's further away, it gets closer and closer and closer, like a fractal. So this is a nice step up from the last program that I made, which was just the last version of this, which was just boxes. So I'm gonna perhaps try to create a maze of some sort, some kind of walled system, I guess. But I want to know what you guys think. All right, I'll talk to you guys later. See ya.